So today I got a little bit of like a special discussion session for you guys. Oh, Jesus, guys, this is so complicated.
Wait there.
Yeah.
Okay, try him. Okay, that's all. Yeah,
Okay, now it goes off.
Yeah.
And now I have to switch back on. Like this?
Yeah, fine. Yeah.
Okay, so today we got a little bit of like a special kind of session where we're gonna
Okay.
work through a little like documentary at the end that came out recently. I don't know if you guys know it. It's about Anthony Weiner, who used to be a politician in New York. He was running for mayor, and he got involved in some
Child abuse?
What?
Child abuse?
Well,
Photo
so the documentary is before that, and then yeah, so yeah, we're gonna watch that later. But and I have like a couple of examples from there. So, but today, as we had the lecture on Monday by John Gratch, I'd like to show you a couple of things of my work where we apply effective computing, and in that particular realm, I would like to talk about emotion recognition, and mainly emotion recognition from speech, and I'm also going to talk a little bit about facial action unit recognition. And I think I've shown you this slide already, but what we're interested in is like how nonverbal behavior and facial expressions here, for example, the dynamics between two individuals are related to like emotion, affect, the situation, interpersonal dynamics, and what's going on. And this is really multifaceted, and I would like to emphasize this by showing you two examples of it. One is speech emotion recognition, and the other is facial expression emotion recognition, and you can imagine that putting those together would also actually improve our results. Again, we're combining different types of techniques, and this like little presentation today mainly focuses on the signal processing aspects, or like the computer vision aspects of emotion recognition and the machine learning. And in the machine learning, I would like to show two like really novel methodologies. And the main idea of what I want to show is the idea of representation learning, where like in the usual cases, like what you did for the homework, for example, is like you get a video or like an audio signal, and I'm like giving you feature extraction like algorithms like the pitch tracker. So what's my fundamental frequency of the voice, or what are the facial expressions, and like it goes through the video and it picks out your eyes, it picks out your nose and mouth, and it tracks whatever changes over time, and it like flags, okay, this is a smile, this is a smile, this is a smile. So these are like pre-designed feature extractors. In representation learning, we don't give the machine this information. We don't tell the machine, look for smiles. We don't tell the machine, look for fundamental frequency. We let the machine entirely discover everything by itself. So it doesn't know anything about human behavior. It gets just a lot of it. And then we tell it, okay, try to find whatever is interesting in this data. And so here are two examples. These are basically manifolds, or like spaces, multidimensional spaces that have representations in it. And so, for example, here you have like a car representation. So these are all the dots of example cars. They're kind of close to each other. And here would be like the prototype, or the centroid of these. You have horses here and dogs there, and cats are similar to dogs, so they're kind of close, but they're off the manifold because we don't have a lot of data for cats. And so the machine learning algorithm just looks at a picture and tries to find like whatever patches in the picture are interesting to it, and like projects it to this space. And here you have like a word, and in this case a multilinguistic manifold of like words that are close to each other. So this is kind of like what you have maybe heard about the word-to-back representations, where you learn from a vocabulary vector, like you have, I don't know, like 100,000 dimensions, so every dimension is a different word. And the word I is, for example, the 50,000th dimension, and it would be a 1 there if the word I is said and everything else is 0, so that's a sparse but very large dimensional representation. And so what we learn in these representation learning approaches is like to convert this very large dimensional like input to a dense small dimensional input. So that one dimension, for example, has a relationship of gender, for example, or here are relationships between capitals and countries, and you can apply the same geometric operations on all those words. But we're going to come to this at a later stage, more in the lecture. So let's do some speech recognition, and I would like to kind of speech emotion recognition, and we're going to do a little bit of like this representation learning, and you'll see how this looks like for that in our work. But before we get there, we use the data set. This is a USC IMOCAP data set. It's like 10 dyads, so two people talk to each other for about an hour each. So we have about 12 hours in total. We have always, a dyad is always like a male speaker and a female speaker talk to each other. And we have two different types of data. One type of data is they improvise and just talk about anything. And they might shout at each other, they might like tell each other jokes, etc. So that's improvised data. Then we have one other half of the data is they are told to express a certain emotion. And they are actors, so they're from the cinema school. In total, this is our data set. We have about 1,600 happy utterances, about 1,100 angry utterances, 1,000 sad utterances, and 1,700 neutral utterances. And these utterances are like annotated in two ways. So on the one hand, you have the annotations by like act now angry or act happy. But on the other hand, you also have annotations by a third person that looks at them or listens to the interaction and like flags, okay, this is a happy utterance, this is a sad utterance, okay? So these are kind of like discrete emotions that we looked at in this data set. What we did is we employed this unsupervised learning algorithm that we're going to touch upon in the lecture as well, which is an autoencoder. And the cool thing about an autoencoder is that it tries to take an input, presses it through a bottleneck that makes it encode or learn something about the data, and then it tries to reconstruct the data at the output. So in a sense, this machine learning algorithm can learn from infinite amounts of data, and it doesn't need any labels because the input is the label, right? So it can learn from the input to produce the output. And the interesting part here is that it pushes the data through this very narrow bottleneck. And if it didn't have a bottleneck here, it could just learn a trivial representation, right? So if the input and the hidden layer and the output had the same dimensionality, what this could learn is like just once for each connection and just reproduce it perfectly. But that would be dumb, like we wouldn't learn anything, right? So what we do here is we press it through this very narrow bottleneck so that it has to learn something about the data. So it needs to combine weights from this input to all of these hidden layers and then reconstruct from the hidden layer activations what the output should look like. Okay? Is that kind of concept like more or less clear how that works? And we're going to get into this in more detail, and I'll show you also ways how you can actually learn interesting representations in the hidden layers, even if they are larger than the input layers. So that's going towards the sparse coding of data that you might have heard about. So, but just for your information, these are kind of like our architectures that we use. These are the numbers of neurons in each layer. So we have, for example, like a 5-layer neural network that performs quite well. And then, but the best performing one is this guy here that gets as input nothing but the spectral filtered audio signal. So we did not do any filter extraction on the audio. We just did like a spectral analysis. We look at like which frequencies are present in the audio, and that's what the network gets as input. Okay. So there's no feature extraction done on our side. So everything that like the network learns at this point is learned from the data itself. Okay. So I'd like to show you a couple examples of how this looks like. So in affective computing, we have on the one hand we have the emotions like angry, happy, sad, etc. But then we also have two other like dimensions that are kind of orthogonal to each other. And one dimension is the valence dimension, so from positive to negative, and the other dimension is the activation dimension or the arousal dimension, which is from passive to active. So in this case, you see the red dots are highly active and the blue dots are low activation. So somebody is passive down here and somebody is very active up here. And you can see that the representation that was learned by the network is kind of like a gradient in this direction, where you have low activation down here and high activation up here. So this is kind of something what we would like to see the network learn, but it never had these labels as input, right? So the network only learns from the data itself. If we look at the valence dimension, it doesn't look that great anymore, but we still kind of have like a lower lower valence down here and higher valence up here. So we again have kind of like a gradient in that direction. However, there's a lot more red in between here. That means we can't learn this separation that well. Yes?
Are there different colors speakers or emotions?
Emotion. Yeah, and it's like these are continuous labels, and so it changes from like -2 to 2 or something like that. And here you see it with the actual emotion. Down here, yellow, so you have low activation down here. So these are always the same, right? These are always the same representations. And we just color them based off of their actual labels, but we never give the network the label for learning, right? So down here, we have sadness, which is low activation and low valence, right? So that's a sad sounding voice. Up here, you have the green dots, which are high activation and more or less high valence. So that's, which one? And high valence means positive valence.
Yeah.
That's happy, exactly. And then the red one, that's kind of like spread all across here, gets labeled with low, but also sometimes high, and here the same, negative, but also sometimes positive. So it's kind of like in the middle. That's neutral. And the interesting part about neutral is it's so spread out through the entire representation, because neutral is the one emotion that everybody speaks differently in. Like everybody has a different modal tone of voice. Like my current emotion is probably kind of neutral, and like it is the one that humans are kind of like most differentiated by, because it is influenced by gender, by personality, by mood as well, and so it's kind of this very fuzzy concept, and actually the annotations on these two emotional dimensions are also not very clear. So individuals listening or watching neutral emotion don't really always know what's going on either. Okay, so that can be quite difficult. All right. So our results are in this case that we have very strong separation for sad because it's like kind of down here, but we get very weak representations of happy and angry. And so they are very overlapping. So blue and green up here are quite overlapping. And so what this means is that we get a good separation on the activation dimension, as I showed before, but a bad separation on the valence dimension. And this is actually something that haunts speech recognition or speech emotion recognition research for like the last 20 years. It has always been the same way. And my hypothesis in this case is the following, that the presentation of emotion in these high activation like emotions like happy and angry are dominated by features that pertain to the intensity of the voice, the tenseness of the voice, and the nuanced subtleties about the differentiation between happy and angry that we humans know about because we also listen to what the text is, and we also look at the face, and we also know the context. So we can infer these things very easily, but a machine that doesn't know anything about that has trouble with that because the features are so dominant that they are actually quite similar in both kind of emotions. And these features are mainly like speech intensity, the fundamental frequency, and the lower values of the MFCC, so the MFCC 0 through 3 or something like that. They're very similar in those both emotions. So that's kind of difficult for us. So again, to reiterate, like we have weak separations along the valence dimension, which is here, but strong separations along the activation dimension. And just for a recall, like this is the activation valence or arousal valence wheel where you have these orthogonal dimensions, and you can see like on the outskirts here, like what kind of emotions you could like add to this, okay? All right. So we want to now kind of like tackle this approach, or like tackle this problem with a new model, and in this case what we're employing is a DC GAN, which is a deep convolutional generative adversarial network. I'm not going to go into too much detail here, but what the main idea is on like how to improve the representations between valence dimensions in this case is that we don't just use our data set that is emotional, but we also add a new data set that is a lot larger than our previous data set, which is 10 times as large, with over 100 hours of data. But what it does is, and it's not emotional, it's a meeting corpus. Like people are like not getting super angry or super happy in meetings. Like it's kind of like just more or less around the neutral emotion level. But what we cover is we cover a lot more different nuances in the speech of different individuals, and we cover a lot larger data set. The DC GAN, in a little bit of detail, is basically it's constructed by two different kind of networks. One network, and these are kind of mirrored networks, so they look the same. One network is a generator, and it's basically so if in the first case, like if a neural network like goes from a low representation to a wide representation, so that's kind of like how the generator looks like. So it gets a small number of inputs and produces a large number of outputs, and the discriminator gets a large number of inputs and produces a small number of outputs. Okay, in this case, it produces a 1 or a 0. And what the discriminator tries to do is it tries to identify if the sample was generated by the generator or if it came in from the real samples. Okay, so we have the pool of data that's there, it's the real sample data, and we pick randomly those, and we pick from the generator randomly generated samples and throw those all into the discriminator, and tell the discriminator that it has to learn the separation between those. So in the beginning, the generator will generate random stuff, right? So it will be very easy for the discriminator to discriminate this is actual speech or this is random speech, right? But they play like this min-max game where the discriminator and the generator try to trick each other over like who is like generating better or discriminating better samples. But through this trick of like generating samples and having some real samples, we can again learn from infinite amounts of data, and we don't need labels because we generate these labels on the fly. We say zeros and ones, okay? So this guy can learn very, very complex and very interesting representations of the speech. And then, in order to do classification, in this case valence classification, we just add a new layer here and then learn a little neural network on top of this. So this is just kind of like a hybrid between a DC GAN and a neural network classifier. Okay, so this is what we try to do in this example. And what we find is that if we just have a normal basic convolutional neural network, we only get like 38% correct on the valence, but if we use the DC GAN, we improve about 5%, and this is a pretty big jump actually. This is very close to the actual current state of the art on this data set. And this is also the confusion matrix, so that's kind of like nice to have as well. But overall, I would like to kind of give the impression that one thing that we learn in this experiment is that just adding new data to a network to learn from something that it hasn't seen before, and that sort of relates to what we want to do, it already helps by improving the classification and to improve the learning or the learned representations of the data. All right. Very quickly, we can go into another experiment where we want to recognize facial expressions. And in this context, I would like to introduce a facial action unit detection network that we built. This is again a convolutional neural network, and this is how the convolutional neural network works. So it gets a picture, and then it has these perceptive patches that move around on the face, and they then get projected onto these inner layers. We have different sorts of filters, and then they get pooled, which means that we average or sum or max over like a certain patch, and then we project that to an inner layer. Then we do another convolution of this layer, and we max and pool here again, and then we have like very small patches at this level, and then we just have like a fully connected neural network on top that basically extracts or like tells us what facial expressions are there. The new thing here in this network is that we don't learn a network for each facial action unit, like for smile or for like the little wrinkles around the eyes. We learn a network for all of them at once. So what we try to leverage here is the fact that even if I don't see those wrinkles, but I see a smile coming up, that I could infer that these wrinkles are there in my data because they are often very correlated with each other. So I could repair findings in my network based off of like what data that I had. And so this is what we came up with. And so our network learns like on two different data sets. And so we approach baseline on the first one and like outperform baseline on the second one. But what's really cool is if we learn on one data set and test on different data sets, we still don't lose any performance. So this is like pretty awesome that we can transfer learn between multiple data sets. And then here we have another data set that we train on, and we test on the opposite data set, and again, we get pretty good performance. So this is very promising and a very interesting result. And as I mentioned earlier, what we want to do is we want to leverage the correlations among the different facial expressions. And what we have here, for example, are the ground truth labels. And you see that, for example, AU1 and AU2 are highly correlated with each other. These are like the eyebrow raisers. And then we have AU2 and this is AU2 and 5. They are highly correlated. But then also, that was the one that I wanted to highlight, is AU6 and AU12 are also quite correlated. And that's also what we find here. At AU6 are the eyebrows, like the wrinkles around the eyes, and AU12 is the smile. Okay, so these are some findings that we had in this data set. All right. But some of the challenges ahead that I would like to highlight here is that often these emotion recognition experiments are done on acted emotions, like we had the face extracted directly, like so we only saw faces, we didn't see any background, we didn't have to find the faces first. We had actors speak into a microphone in a certain emotion, so they knew what to do. There was no question about like, okay, is this actually happiness, is this actually anger, because they were told to act like that. So there's always these difficulties, and like usually we learn in one single data set, and these experiments today were kind of exceptions. And as I mentioned, the emotional expressions are often acted, but what happens if they're real and if they're not acted? And what emotion does a person feel? Like, do we really actually know that? Can we always ask the person, like, hey, how do you feel? What's going on? And I think we cannot, and I would like to kind of give you an example, and let's just watch a documentary if there are no more questions. And I'd like to show you this documentary because I think I've seen like some of the most genuine and real emotions in this documentary, and we can just like look at a couple of examples and discuss those among ourselves and find out what we believe is going on for real. All right, so let's do this. So the documentary, as I mentioned, is the documentary about Anthony Weiner. All right, so I'm just gonna play the first 2 minutes so you get like an idea of like what's going on. And who Anthony Weiner is.
This is the worst. Doing a documentary on my scandal. Hi! I don't know. I guess the punchline is true about me. I did the things. But I did a lot of other things too.
Mr. Speaker, I yield 1 minute to the distinguished gentleman from New York, Mr. Weiner.
Gentleman's right.
Great courage until all members have already spoken, and then stand up and wrap your arms around the procedure. You vote yes if you believe yes. You vote in favor of something if you believe it's the right thing. If you believe it's the wrong thing, you vote no. We are following a procedure. I will not yield to the gentleman, and the gentleman will observe regular order. The gentleman will observe regular order. It's Republicans wrapping their arms around Republicans rather than doing the right thing on behalf of the heroes. It is a shame. A shame. If you believe this is a bad idea to provide health care, then vote no! But don't give me the cowardly view that, oh, if it was a different procedure, the gentleman will observe regular order and sit down! I will not!
It's about...
Right. So, what do you guys think you saw in the beginning? Like, so first of all, I think he starts off basically with the punchline about the whole thing. It is about his scandals. He did it. How did he feel about that? Like, it's remorseful. But then he also, like, he was on the phone, right? Trying to call somebody. And immediately, like what John Gratch was talking about on Monday, right? He switched his tone and like he knows he's observed. He cannot act like that in front of others, so he switched the emotion immediately. So to convey a different kind of personality. And then here, I guess it's pretty obvious, like what he did in Congress there. He's happy about what the Republicans did, or
Outburst.
he has an outburst. He's really angry. And let's go forward to. I hope I can see this. To 20 minutes into. Can you tell me when it's 20 minutes? Is it like here? 18. Oh, this is 20 minutes, right?
18:35.
Yeah, that's fine.
That's good.
So, something that I feel is most interesting about this documentary is the emotional development of this character here. And it's Huma Abedin, who is the wife of Anthony Weiner. And so she has to live through all of this kind of emotional turmoil. They have a kid together, and she's campaigning with him. She's on the phone trying to get funds for his campaign. So this is how she's acting in this one.
It's Huma. How could you tell my voice? I haven't talked to you in a year. How was the engagement? I want all the details. What is perfect engagement? Well, congratulations. Yeah. Well, he's working very hard. Okay. I'll talk to you soon. Have a nice weekend. Bye-bye. All right, he'll max. His wife is going to max out. And he'll try to raise another fine. He's like, I'll never be able to raise in my life. And,
Shame. Hey Joe, it's Anthony Weiner calling.
it's Huma.
Anthony Weiner calling.
Hello, Joe.
How are you, my brother? How are you, my brother?
That's true. We have a long history together.
How's things in the shop? How's the family?
Oh, really?
Hey Mike, I was wondering if
If you call your friends and they're willing to write checks,
I haven't asked you for 2 years. I give you a nice long break.
you're the leader in the community, so they're going to listen to you.
$4,950 per person, and $9,900 per couple. It's nice you say, now is it 20 to be in on Monday when you're going to bring with you?
I feel very awkward about this with
Are you married?
You're a good friend. Good to hear your voice.
250. 5,005 minutes, that's not bad. You did well.
Bye.
All right. So what do you think?
Just tolerating it.
I mean, at this point, I think the first scandal is behind quite a bit.
Yeah.
And so they're putting up a show for the donors, or like it's genuine. What do you guys think?
Fake.
Fake?
Niceness.
You think maybe she's really just...
They're pretty good at it though, right?
Oh, yeah.
So yeah, I guess that's kind of like what you have to be as a politician, really good at like getting money. So this was Huma on the phone then, and this is Huma on the phone after the next scandal.
You know the timing of any of this?
No. I don't.
Not at all?
I mean,
So another scandal just broke.
Okay.
that's separating. where are you on the statement?
I can't get through to them on the telephone. We keep getting interrupted. They think that this is not going to work. They think this is whatever. I don't know. I'm like very anxious about you and I being apart today. Someone can find you.
Yeah.
Listen to someone at the phone.
Hey, Candace. No, but Anthony's just trying to get you on.
Hi. Well, you're saying that the timeline is the problem. Yeah. But okay, so go ahead. Obviously, look, this is a continuum of challenges in our marriage that ended at a certain point, and we decided to move forward with our lives, and that was a problem, and that's behind us. As we said, other things could come out. No. Getting obviously, we're getting deluged. Well, my head is at trying to sell this as something that people already know.
So, don't stop there. So, what do you think was going on there?
She's not happy.
She's not happy. Are there certain, like, specific things that you observed about her?
Her head shaking. You're like, I can't believe you.
Head shaking.
Like,
Fidgeting.
back and
Back and
forth.
forth, like pacing around, with the fingers on the table, like not able to listen, like hold the phone down. And, okay, can you tell me when it's 34:11? Am I past?
Yep.
Okay. So you see, she's wearing the same clothes. This is right after. She now addresses the public in a press conference.
A lot of work and a whole lot of therapy to get to a place where I could forgive Anthony. But I made the decision that it was worth staying in this marriage. Anthony's made some horrible mistakes, both before he resigned from Congress and after. But I do very strongly believe that is between us and our marriage. So really what I want to say is, I love him, I have forgiven him, I believe in him, and as we have said from the beginning, we are moving forward. Thank you very much. Thank you for your
So, fast forward, like, her behavior changed quite a bit. She sounds like what? Like, do you have any ideas?
What's she standing by her man? I don't know.
Standing by her man. She transitions there from like it feels like some almost like forced smiles in there to almost starting to cry, and like it's very powerful. Like these dynamics in her behavior are really like what I think is really fascinating about kind of like this the realness about these behaviors and the realness of like what's going on in this marriage. I mean, it's kind of like almost like voyeurism, but it's very strong and very powerful. So this is kind of some of the things that we have to deal with. So like there might be like emotional transitions are very quick, and so like they can be like 2, 3, 4 seconds, and our models need to pick those changes up very rapidly. And so yeah, this is another interesting interaction. And I'd like to go to 4905. Oh, there it is. So Anthony Weiner now think there was another scandal, and he is going on TV now with this guy called Lawrence O'Donnell, like Last Word with Lawrence O'Donnell. It's in the NBC studios, and as a disclaimer, like you don't hear Lawrence O'Donnell, you just see Anthony Weiner react in the studio.
Joining me now is Anthony Weiner. Thank
My pleasure, Lawrence. How are you?
For me, it just comes down to this, which is, what is wrong with you?
I don't understand the question. What is wrong with me that I care so much about the issues that I fight for every day, that I have my entire career?
No.
Are you saying that because I have things in my personal life that are embarrassing, I shouldn't run for office? Okay, that's a fair position to have. Some people have it. Well, you're not being clear, Lawrence, so let's work a little harder at that.
It does not seem to be a fully healthy pursuit.
I know there are a lot of people, there are a lot of people who talk about
the totality of your life, Anthony, do you think you've spent your time well?
First of all,
Anthony, I think there is something wrong.
I know you just said that. You just said that. Repeating it doesn't make it any more interesting.
I'm looking at your life. I'm looking at your relentless pursuit. You are relentless about certain things.
That's not true. That's not true. That's not true.
What I'm trying to get at, Anthony, is what drives you.
Okay, in that case, ask me that question.
Office.
You don't like things that you know about me. You want to make fun of me on television. Join the club. Frankly, bigger guys than you have been trying to knock me down.
I mean it from a psychiatric level.
Dude,
I don't care.
Dude, I don't really need your psychiatric question. All you can focus on is what's wrong with you? What's wrong with you? What's wrong with you? That's not aids the debate either. I don't plan on losing. Maybe I'll come on this show and kick your ass every night, like I'm doing tonight.
You'll get the last word.
Thank you. Good night, Lawrence.
That was quite interesting as well, right?
Yes.
So, what's going on there? Shameless. I think one of the most interesting ones is like when he says, maybe I don't plan on losing. I think that was very quick shift in
Frankly, bigger guys than you have been trying to knock me down.
I mean it from a psychiatric level.
Dude,
I don't care.
Dude, I don't really need your psychiatric question. All you can focus on is what's wrong with you? What's wrong with you? What's wrong with you? That's not aids the debate either. I don't plan on losing.
that was really like very real, right? And then I don't know what happened there, but like he went into this very fake kind of like power position.
Maybe I'll come on this show and kick your ass every night, like I'm doing tonight.
You'll get the last word.
Thank you. Good night, Lawrence.
So then a little later, he is discussing the situation with Uma again.
Have a life that's embarrassing. No, congratulations. You can get on the list, but I ultimately don't care what you think.
I never once criticized you for your texting. I think your photography is just perfectly standard American photography that's floating around the internet now. I've never said anything about that.
You just believe that I should have run once I have. Even if I took on the better candidate with the better idea, don't run. I don't problem with don't run.
You knew, Anthony, that you were a gravely damaged candidate.
I said so. I didn't
What do you think looks better near him? At least in the online version? Will we continue?
Why are you laughing? This is crazy.
It's it's terribly crazy, but what was I supposed to do? I mean, tell me what I was supposed to do. This is where it continued.
No. Focus on your speech. Can I start from
This makes me feel better. This makes me get more fighty, less emotional. A little better. And we got better here because you realized how the other thing went, I think. How's the other thing? For me? What is this to do? Whatever the opposite of that is what Homer is. She looks like that argue, right? No, I don't think she may.
Huma Abedi. What is the simple explanation?
All right.
She discussed it with him, totally.
At this point, yeah.
She's like,
I think it's very, very interesting the way they interact, and like what I feel is so interesting is that these two totally different characters are being filmed in this documentary, and like he clearly kind of wants to be in the spotlight, and he likes to be public and tries to explain what's going on. She has no interest in that whatsoever. I think like that all these scandals are just too much for her. All right, let's take a 10-minute break then, and get back with. This is a special request for the second group. Abhishek needs to go somewhere soon after the class. So if the second group can start presenting the discussion first, and then we go to the first group. All right. Let's get back here at 9.